Welcome to Schweitzer Drive, a podcast where we explore what goes on between the generation of electricity and the light switch. Join Dave Whitehead as he interviews the entrepreneurs, innovators, and experts who are inventing the future of electric power.
Hi, I'm Dave Whitehead, and my guest today is Dr. Steve Pekarek, a returning guest on our podcast. Steve is the Edmund O. Schweitzer III Professor of Electrical and Computer Engineering at Purdue University. Steve is an expert and actively researching a number of topics that I'm really excited about and will bring great benefit to all of us, including predictive power system control and the electrification of roadways. Steve is an active member of IEEE Power Engineering Society, the Electric Ship Research and Development Consortium, and the Advancing Sustainability Through Powered Infrastructure for Roadway Electrification Center, or ASPIRE. Steve earned his PhD in electrical engineering at Purdue University. Steve, thanks very much for talking about power electric vehicles, or mobile loads as I think they're referred to these days. It's a really interesting topic, I think, especially given all the excitement from Tesla to Ford to GM. Everybody seems to be coming out with new EVs. I think Volvo said that they're going to be all electric vehicles in the coming future. So I think it's an interesting topic. There's a lot of excitement. Of course, there's some technical challenges that go along with, say, everybody having an electric vehicle. And depending on the state you're in, there are some near-term mandates for electric vehicles. I believe California has a mandate that all new cars sold in California will be electric by 2035. And many of these mandates are based on policies or politics. But what technical challenges do you see that we need to address to meet these mandates? It's going to be a challenge, I think, to be able to, for everybody anyway, to be able to drive an electric car.
Well, thanks for having me, Dave. And yeah, it is going to be a challenge. I think the big challenges that we see right now are the challenges of cost and range anxiety. So, it's people worried about their pocketbook and then getting stranded. And those are the two things. And we're used to an infrastructure where recharging a gasoline or a fossil fuel-based engine is relatively straightforward. And so how do we go about doing that with an EV? And that is at the forefront. And of course, like I said, associated with that is the cost of putting that energy storage onto a vehicle.
Yeah, it's depending on the charger type, right, can dictate how long it takes to charge your vehicle, right? If all you have access to is 120 volts AC, it could take a long time to charge a car versus some of these fast chargers. I think Elon Musk said he wants to be able to charge one of his Teslas in under an hour, and I think that comes out to, 250 kilowatts of power required to charge those batteries in that time. So what do you see as challenges for that, or am I missing something?
No, you're exactly right. Those are the superchargers, right? The 480 volt three-phase based chargers, but in the home, certainly we're at a lower level of charge, and you're talking probably on the order of a level 1, 120 volt charger, maybe 5 miles per hour, a level 2, maybe 15 to 25 miles per hour. And that's not the speed, that's the speed of charge. So, those are the technical hurdles, and we would like to increase that, of course. But the challenge there is the battery technology is what limits you on at the power levels we're dealing with. It's the battery technologies will only accept some. But in addition, you wouldn't want a megawatt level connector at your home in all likelihood. You might, Dave, and I might, but I think the general public might run from that.
Yeah, I don't think my wife would. Maybe I don't want one. But this is all interesting on how do you practically deploy lots of EVs throughout a city or a neighborhood. And that gets me to my question of what technologies are you researching in regard to EVs and these charging problems or challenges?
We are at Purdue part of an inspirational center called Aspire. It's an NSF center, National Science Foundation. The Aspire stands for Advancing Sustainability Powered Infrastructure Roadway Electrification. So big, long acronym, but if you were going to boil this down, we're trying to create ubiquitous charging. So as one of the technologies, for example, is dynamic wireless power transfer. As you are driving, for example, on an interstate, you would be within the roadway, there would be a charging system and your vehicle would have a receiving system. And as you're driving over that, you are being charged. And so what that does is it enables you to reduce the battery size within the vehicle, and so reducing cost of that vehicle and hopefully reducing range anxiety because you have the capability now to be dynamically charged. So that's one of the key aspects or technologies we're considering right now.
So that kind of sounds like sci-fi stuff, right? If I'm understanding you correctly, this is kind of like induction. Like I can set my iPhone on a little pad and it'll charge up while it's resting there. And yours is I'd be driving my car down the road and it's going to through induction or I assume it's through induction. Right. It's gonna charge my battery, which kind of seems like something I'd see on the Sci-Fi Channel. Where are you guys at with that research, and when it might it be at least testable in a practical system?
Well, I think it's already been demonstrated in different parts of the globe. Auckland University, for example, in New Zealand, in Korea, in Europe, where we're dealing with powers, for a typical vehicle, a sedan. People have demonstrated this and actually put it commercially for buses. I think where we're really trying to push on this level is to consider this for like heavy duty vehicles, because they are one of the dominant sources of, fuel or fuel use and also emissions. So we're looking at the technology dealing with heavy duty trucks and trying to get that deployed here in Indiana within the next 5 years. And it's a significant undertaking, but I think is possible.
So that's interesting, targeting big vehicles like I would imagine semis or trucks or something like that. They're on the road a lot. They consume a lot of fuel. So targeting that market seems pretty interesting. Have you seen any interest from, say, a UPS, a FedEx, an Amazon, people that are driving trucks all over the place all the time?
Yes, we have. There are numerous companies and also those that manufacture the large trucks as well. Yes, there is certainly an interest level. There's also interest at places like ports, where in California, as vehicles are unloading and loading ships, there's oftentimes a need for, or they would like to utilize the wireless charging capability there. So there's a host of industries, there's a host of companies that have been and are part of our center.
So what technologies need to be developed to make this practical or realizable?
I think that the challenge is, you said it correctly. You stated that you thought this was going to be inductive, and indeed that is what in all likelihood would be present. So what does that mean? That means you're going to have some conductors, electrical conductors, placed within the concrete. And you're going to then have to bring the power to those electrical conductors. And so the technical challenge is, how do you do that cost effectively? And how do you do it so that the roadway still maintains its integrity in the presence of relatively large power levels that are passing through. So some loss associated with this. And then how do you set up your grid infrastructure in such a way that it facilitates, charging many vehicles, a typical traffic pattern on the worst of days. Those are the main challenges that we're trying to address.
And then what kind of power levels are we talking about, right? If I'm remembering my Maxwell's equation is I can send current down a line, that'll create a magnetic field. How much current am I talking about sending down to create the magnetic field?
Hundreds of amps, Dave. It's unique. So it's interesting to think how much power is required. And I'm talking about just if you were going to keep a vehicle at its sustained power level. So you're just overcoming the energy that it's using as it's driving down the road. A large semi-truck, one trailer. It doesn't have to have 2 or 3 trailers, just one. You're dealing with probably on the order of 220 kilowatts continuous that has to be supplied to that vehicle. And for those that are interested or wanting this in terms of a different number, think of you're continuously powered for one vehicle about 200 homes. So we're dealing with large amounts of power, and your current levels, like you said, Dave, are significant. What's changed, though, and power electronics enables this, is they're at very high frequencies. So we're talking about fundamental currents not at 60 hertz, like in a traditional power grid, but maybe 20 kilohertz. So much more rapid. And so that enables that energy transfer.
So there's another, this is really getting fascinating too. Now we can get really geeky. So now I get the idea of cranking up the frequency for this thing, but now don't you pay the penalty for skin effect in the conductors you have? And these conductors are going to be pretty long too, right?
Yeah, this is great. We're in Nerd Central now,
Man,
Dave. Yeah,
I know.
they are. I love Nerd Central. There's a particular type of wire. It's called a Litz wire. It's a specialty where you are, in essence, taking these individual conductors and wrapping them in such a way that you reduce the impact of that skin effect and those losses, and so it's more efficient.
You've solved that problem then.
Well, on paper, Dave, we've solved it. We always like paper, and we'd like to just walk away and say done. But until we actually implement it in practice, Litz wire has certainly been around for a long time and is in a host of applications. Where we're being challenged is at the current levels that we are requiring and making the connection. So we think we've solved it. But until we can, in a few months, Dave, we'll have another interview and we'll tell you if we've solved it.
Well, that sounds very, very interesting. So we got power electronics that help us with switching. We've got hundreds of amps. We've got skin effect challenges, and Litz wire sounds like a solution that you guys are exploring. Are there any other research areas to allow me to charge my car as I'm driving down the road that need to be addressed?
I think there is a large initiative on battery technologies, how to store more energy there in a smaller package, how to charge faster. You see right now, if you purchase charging equipment for your home or look at some of the literature associated with it, it's all about the charge rates that they can do and getting it higher and higher. And so you might see in the literature, we're going to a megawatt level chargers. And so that's one of the things, is trying to, in twofold, trying to get a better battery and then trying to increase the power levels that you can transfer to that battery. So those are kind of two things The third is setting up, where does this make sense? Where is this economically viable? Do you put this on every interstate, for example? Do you put it on select interstates? How do you deploy this? And that's another whole level of challenge associated with the power system.
Oh, sure. Speaking real quickly about batteries, do you think we'll make a quantum leap or a 10 times improvement in battery storage or energy density in batteries? Folks have been working on batteries, whether it's lithium ion or all kinds of different chemical technologies and stuff. But from my perspective, I'm certainly no battery expert. It seems like we kind of hit a plateau. Whether there can be small incremental improvements, but there's no, I don't know, looming big 10 times improvement or something like that. And are we going to get to a point where batteries are what batteries are, and they're never going to get us to, say, probably the energy density of a gallon of gasoline or something?
Well, I think getting to a gallon of gasoline, that would be multiple Nobel Prizes is my guess. I'm not a battery expert, so I can't say exactly where they are on the curve. That's what we'd like, right? Is kind of a Moore's law type of curve, and say every couple of years we're going to get this improvement and then see some kind of step change. Right now, certainly there's been a massive improvement over the last couple of decades, but I haven't seen anything recently that would say, hey, this is going to be a step change and an entire game changer because we can pack more things in. Is there funding that is out there to do that? Yeah, I know for a fact that many companies and national labs are searching for new materials and new battery technologies. But I have not heard of anything that is at the stage of a game changer yet.
Interesting. So that brings me to kind of a great follow-on question is, do you see alternatives to EVs advancing, whether it's, fuel cell-based, hydrogen, advanced diesel, combustion engines? Aircrafts consume a great deal of fossil fuels. Are EV adoption in aircrafts on the horizons? What are your thoughts there?
Yeah, I'll answer kind of that last question first. Because it's kind of an interesting thing. Viewers can look up on experimental aircraft and they can come across, NASA has several programs where there is a drive toward more electric aircraft, certainly. And an all electric aircraft is kind of a dream. And it's interesting because it considers the aerodynamics associated with it and replaces, for example, the 2 or 4, however many engines or turbines that are on it, with small electric machines that are placed across the whole wing surface. And this enables a more efficient transportation vehicle, and as a result reduces the battery necessity. And so there is a push toward this. And indeed, I think people are moving toward that. In terms of the alternatives like fuel cells, certainly those capabilities are also under exploration. But I kind of put fuel cells, and I'm sure all of your fuel cell listeners, Dave, are going to send an email to us or contact us after I say this. So I won't give my email address. But, fuel cells to me have been in kind of the battery mode where I have that connotation that, yes, they are making progress, but they are still somewhat far behind and not progressing in such a way that I see, they're going to overtake a hybrid vehicle or an all-electric vehicle. That's where I kind of think of the fuel cell. In terms of the alternatives, like a hydrogen-based, people can consider that there's hydrogen proposals where you would have hydrogen storage and hydrogen-based vehicles. And I think the question there that people are trying to deal with is, how do you get that hydrogen to your respective, how do you make it ubiquitous? And is it better to make it ubiquitous, or is it better to bring in the electric vehicles and have these charging stations and have that be ubiquitous. And I think presently, for a host of reasons, probably many I don't fully understand, the EV has really been more dominant than the hydrogen-based fuels.
Yeah, hydrogen I think is interesting. Maybe you could make an argument that the infrastructure for hydrogen maybe is not, it's different, but maybe not too different in how you'd actually go about deploying hydrogen gas stations, kind of like what we have with gasoline gas stations right now. Maybe there could be an argument for that. I could see. And I'm scratching my head. I should have done maybe a little bit more homework. I don't know what the hydrogen density is compared to gasoline, compared to what you can store in a battery. But I bet that the hydrogen is somewhere between the what's stored in a battery and a gallon of gasoline or something like that. So that's interesting.
Yeah.
Hey, I was watching the news the other day, and you got me thinking about the battery based aircraft. I know there's a startup in I think it's Palo Alto. It's like a 2-seater, 4-turbine blade aircraft car, if you will, aircraft. And I think its range was like only 30 miles, just because I think you're playing off the weight of the passengers and the batteries versus how much battery you can stick into this aircraft. But things are changing, right? It's going to be interesting where EVs get deployed, whether it's cars or aircraft or what.
Right. Oh yeah, it's always changing, and I think there is a whole push toward that in trying to address mobility. And doing that in highly densely populated areas.
So, Steve, I'm going to put you on the spot. Have you make a prediction. When do you think we'll hit? Let's pick a number. 40% of vehicles on the road are EVs, or you can pick 50%. I don't care what number you pick.
50%. I have no idea. 40%. I may be an idea. I don't know. I guess, Dave, I'm hopeful that we hit that in 2035, that we're,
wow.
In terms of across the country, are we there at that point? And we're talking about all vehicles. Passenger vehicles may be a little more than that, but in large trucks, less. So maybe across the entire plane, hopefully we're selling new vehicles at a 40% at that time.
That's not fair because I'm not even willing to make a guess. We live in a rural area. You guys live in a relatively rural area. I have a Ford F-150 and I love it because it's powerful. I can go 600 miles on a tank of gas. I can pull things with it. So I for a long time, I wasn't really interested in electric vehicles, but you know what? The cars that are coming out from all these major manufacturers, they're really intriguing. I think it'd be a lot of fun to be able to drive an electric vehicle. So I see one in my future, but I think it's more of I'm just interested in the technology and the speed and the acceleration and all that other stuff.
Oh, yeah.
And maybe that's the way we get folks buying electric vehicles. Of course, there's a whole bunch of economic problems. They're kind of expensive, so they're not for everybody right now. But it's interesting.
Cost and range anxiety. Can you overcome those two things effectively? And if you can, then those numbers change significantly in terms of the penetration levels of that technology. But they are exciting.
Yeah, they are. Steve, thanks very much. It's been a great conversation. We're going to have to check in with you, see how your research going in a year or so, just to see where we're at, and maybe by that time I'll have an electric car that you'll be charging as I drive down the road.
Outstanding. Thank you, Dave. It's always an honor.
Thanks, Steve. Talk to you later.
Thank you for stopping by Schweitzer Drive. Join us again as we learn about, explore, and celebrate electric power. For more information about the show, please visit selinc.com/Schweitzer Drive.